The history of science, and particularly atomic science, is often visualized as a linear progression from one model to the next. These visualizations may misrepresent science as a sequence of monotonic improvements by individual scientists while masking the role of other factors such as scientific community, alternate hypotheses, and local circumstances in scientific inquiry. Drawing on historical research and feminist and SDS studies, this project aims to develop an alternative and interactive visualization of the history of atomic science that focuses on these factors and their relationships. On the rightmost side, we see a slider with a selected date. Right now, it's the year 1803. In the main area here, you can see a map of Europe as it was back then. During this time, there were two foundational questions at the heart of atomic science. What are the fundamental constituents of matter, and how do these constituents interact? Let's trace the response to the first question. What are the fundamental constituents of matter? By 1803, we can see that there were multiple schools of thought instead of just one model of the atom. One school of thought believed atoms to be finitely small particles, while the other considered them to be infinitely small. If we click on this latter group, we can see two of the scientists who adopted the school of thought, Leibniz and Poscovich. We can read the description of Poscovich's point atom hypothesis down here in this panel. He argued that not only are all fundamental particles infinitely small, but they're all also exactly the same. In contrast, if we click on Leibniz's theory of monads, we see that he argued that no two fundamental particles could ever be perfectly alike. Even within common schools of thought, there was a lack of unanimity. At this point, I would like to draw attention to a key feature of this visualization. When I clicked on Leibniz's hypothesis, which was published in 1714, the map was transported back to that time. The slider here shows 1714. The other school of thought has disappeared as those scientists were not even born back then. If I click back on Poscovich, the map and slider moves to 1763, the date he published his theory. This kind of navigation lets viewers see the state of science when a scientist published their hypothesis and lends more context to their research. Let's drag the slider down to 1766, the year John Dalton was born, and zoom in to his hometown of Eaglesfield in England. Clicking on Dalton's icon, we can see the different major events in his life. For example, although Dalton was born in Eaglesfield, he moved to a small town called Kendal at an early age due to financial hardship. When I click on this event, we see Dalton's connection on the map change from Eaglesfield to Kendal, showing his movement. We can also learn more about this event in its description below. The aim of these features is to invite connections between a scientist's background and their research and beliefs. The long-term goal of this project is to support the learning of science and history as situated practices. Overall, we hope for the project to become a rich platform for research at the intersection of history, science, and digital media. Thank you.